Today we're lucky to have Anurag visiting from West Virginia University. He came and spoke this morning, and so we just wanted to learn a little bit more about where you're from and what you do. So if you could tell us more about your ECE department at West Virginia.
Sure, yeah. So first thing, I really enjoyed the visit here so far. And, talk was good and a lot of meetings. So about West Virginia University, our department is actually integrated with computer science and ECE together. We work on, a lot of different things, which we divide into the 11 clusters area. In terms of well-funded, it will be AI plus health. We have a center which is called AI plus health engineering center. And we also have NSF IUCRC called CITER, which is for biometrics data. We are probably one of the biggest academic university of a lot of biometrics data and largest repository of biometrics data. In terms of students, we have around 800 to 900 students, depending on the year.
For both undergrad and graduate? Or?
Yes, okay. Yeah. And around 30 to 35 faculty and a lot of adjuncts.
And then how is it divided with the majors? Because you have multiple majors, right? And you can also do dual majors, but between the main majors like computer engineering, electrical engineering, and computer science, how is it kind of divided?
Yeah, so computer science is biggest, almost like 400 something students, and so half of the department is in computer science. We also have a cybersecurity, which is growing area, right? So it came out of computer science and growing now. And of course, electrical engineering and computer engineering. We have a partnership for robotics, which we started with mechanical engineering and aerospace recently. So it's still getting traction. You don't have a lot of involvement in that area. We used to have a biometrics, like separate major, but now it has become minor.
Okay.
Yeah.
Cool. And then what are the three main areas of ECE that you think will be most attractive to undergrad and grad in the coming years?
Yeah, so one thing, looking at the job trends and what industry are saying, I think things are changing, which means that they need an expert, but with exposure to other things. And, so if someone is EE, if they have a minor in, a little bit more about how it interfaces with the real world, will be getting higher traction. So in terms of, the things are converging, I think three things that I'll put on the top is autonomous system, which is basically brings software, hardware, edge computing, edge AI all together, and also sensor and actuator, depending on that where we are using that edge systems. And also, if you look at the complexity of things, that it has changed. So for example, autonomous car probably is going to have a same amount of code as like a Boeing 747 in future, right? So if they learn one aspect of that, and they need to design a new electric vehicle which is autonomous, they need to understand a lot of different parts, because it has to work and it has to work without failure.
Yeah.
So they need to learn more stuff, right? So it's not we used to have systems where you work on one isolated part and worry less about other, right? But now I think they need to be still expert in that what they are trained on, but need to be more aware of other things, right? So other than this autonomous and edge, things, I think cyber physical system security will be another one where, it doesn't matter that you are EE or CPE, you are putting a device somewhere, and security of that is as important as the system security. So, and there's a relation between security at device level to security at the system level, and what impact it brings. So cyber physical systems and security will be important. Third thing, I will say the sustainable power. And that's, again, we see a lot of different like right now, one thing which is very hot is the data center.
Yeah.
So as data center is coming, you have to think about how to power them and how to make it sustainable. Because if you are going to increase more and more data center, and if you don't have enough power to supply them, or it is impacting everyone, because especially in those areas where there's electricity market, the cost will just shoot up with higher load, right? So how to make it sustainable, it's not only about power engineering or grid, it's about, everything, that how you design a chip, how do you put transistor into the computing machine, because you need to think in terms of making the data center itself more sustainable in terms of power consumption, in terms of thermal management. So, again, this brings a lot of interdisciplinary aspect. So I think these three will be important one, which is kind of applied, and but doesn't mean that foundation is not important, because unless they're expert and understand the foundation, they cannot bring that knowledge to enable these three things that I'm just talking about.
Right. And like when you're talking about the autonomous systems and self-driving cars, you also have to worry about like energy storage and like also sustainable and how you're going to do that. And then I just feel like with all the AI stuff, the data centers are really important. And then someone mentioned in a talk I went to earlier today, kind of like how is quantum computing going to play a role into all the AI? So yeah, it's kind of an exciting time. It's going to be a whole new world out there.
Quickly changing world.
Yeah, pretty much. And then in case we see any lapse in federal funding in the foreseeable future, how do you think that ECE faculty can connect with industry to seek research funding? And then, what areas in your department have the most funding and industry relationships?
Yes, in our, I think it's mainly regional, because it depends on that who is not too far from here and where are your student is going, because those are the industry which will come first, because there has to be someone leading the team and motivating them, and okay, let's go, because I work there and I got good education to help with this industry. So I think where the alumni are, that need to be tied in for the industry support. And then one thing that will be a little bit we have to be careful about, that industry wants always applied. They also want ROI, right? Like what will you do? And then also they want to make a profit out of this, right? So actually it's most of them, if not all. So keeping that balance, and in fact, if you look at the R&D budget from like big giant like Amazon, Google, it's a lot, right? And they have also made an impact in the past. Like you look at Google Research, DeepMind, and now OpenAI. So in fact, if you count them all, these just top 10 giant company, their R&D budget will be probably more than NSF, right? But their R&D is slightly different kind, because again, some are fundamental, but mostly are applied. So I think if faculty need to get engaged with them, we already know as being an ECE faculty, what are the area where we can apply, it's defense or telecommunication, or, of course, this AI, ML computing, and electric power, so all of these, or semiconductors. And semiconductors is one of the biggest probably industry, you just look at different industry who are spending more money on R&D, starting with the Intel and the new ones. There's a lot of R&D money there, right? And then this software is more like a CS, but because most of the recent AI ML breakthrough was possible with hardware. So, that's again bring the semiconductor aspect. So I think faculty has to first find out alumni. Second, they need to look at that where their area ties to, and need to be open, because, like defense is slightly different, but not traditional funding that they have been probably following. But there's a lot of application there. And then third, look at present their ideas in a new way, because ROI is more important, applied is more important. And at the same time, we as a faculty, they have to be careful that help technology, which is also in long term helping the humankind.
Yeah, I agree. I think it's important to stay connected with your alumni, and I think that they represent your department and they speak volumes about your department and how it works. And then I also think it's kind of interesting because we mentioned all this R&D that's taking place, but a lot of the PhDs, when you mention a PhD, they think that they have to go to academia, but that is not the case.
No, it's not a case.
Yeah, and I think that's kind of a fallacy. Like they don't realize that.
Yeah.
And so
I remember a story like when I went to Idaho National Lab. I mean, it's a small town, but that's a national lab, and
Right.
they had the highest amount of PhD capita,
oh yeah,
per city at that time. So I don't know if they're still true or not, but
yeah,
yeah.
I know. And people don't think about that.
Yes.
But it's like a really small percentage that actually goes to academia. Like it's mostly in industry or the national labs and
Exactly.
stuff. And so, and then there's the ECE, DHA, the Department Head Association, and what specific strategies do you think a platform such as that should take to enhance like ECE research and education in the U.S. in the coming years?
Yeah, so I think ECDHA has been in terms of connecting people, right? So that they will still continue, which means learning from each other, right? One thing that they need to do, or they can help, is branding. So if you look at all the major breakthrough that has happened in terms of technology changes, right, in communication or AI, I think ECE get less credit for what they have enabled. And if we, learn a way by working together that what will be the best way to promote that, and tell future student and tell industry the importance of ECE, that'll be one thing to do. So how do we do the branding as a community, and everyone is doing together because it's a shared thing, right? Other possible thing will be that most of the university is kind of like operating in its own silos, and there are labs, right, like which can be shared between, or even can be connected together like a co-simulation or to make a powerful lab. Some of the it will be useful and good thing to do, and some maybe connecting them together will result into not a good simulation because the delay is causing the problem, right? So we need to identify that how we can leverage each of the resources, and how do we, hopefully with the goal of reducing the overall cost of operating this lab will be less, right? Still providing what research and education it is helping with. So coordinating the resource, I think, again, because they connect all the departments together, will be another one. And I think in the past, there has been effort of sharing curriculum.
Yes.
And even sometime, like I know that in cybersecurity, there are some organizations like, US Cybercom and then DHS, and they have helped. I think they call it Clark or something, like there is a platform where you can share your syllabus, your course curriculum, and if someone is starting like a new course, maybe it's already being taught at another university.
Yeah, it came in really handy during COVID because I think we were all kind of hit on how do we teach our labs virtually.
Yeah.
And so I think this association kind of helped collaborate a lot of that.
Exactly.
I think it's been really good for resources, and I think they provide a lot of really good seminars and information. And so I think it's been really good.
Yeah, like if you look at every industry has limited resources, every department has limited resources, and they have focused efforts toward one aspect compared to less effort on another aspect, which means that everyone has something to learn from each other.
Yeah, I like it that it's more a collaboration.
Yes.
And so on. And so I think it's been good. And then currently right now, machine learning and artificial intelligence are two of the most popular topics, right? I mean, in the courseworks, in the news. In your opinion, how can ECE faculty contribute to the research in these areas in the most meaningful way? And then what can we do to distinguish ourselves from other engineering departments?
Yeah, so I think, there are two aspects, of course, education and research. In terms of education, ECE is kind of lucky because we have the highest amount of labs. So, which means that students still have to get hands-on, and then AI is impacting them in two ways, right? So one is that learning and homework assignment and all those things, they're getting some help from AI, right? Mm-hmm. And if they do, they don't learn as the same way they will learn without AI, right? Mm-hmm. So, and I think the process of using AI for their advantage, as a faculty, we have to tell them, and also convince them that what we are saying is right. So,
well, it changes the perspective a little bit,
yes,
right? And I think like what your goals are a little bit different, and it's sort of like learning how to incorporate AI into the curriculum, into the learning, and because how they're going to have to use it for their jobs later on as well.
So for education, I think we are a little bit already at least better than other department because ECE has most number of labs, and then a good integration of math and physics, which is more foundational and fundamental. So when thinking about learning process, we are less impacted compared to other departments, like English literature, or compared to even computer science, right? So that's the education part, that how faculty has to leverage their uniqueness in making it happen for better learning of students, because that's the most critical thing. Second, for research, first again, that goes back to the messaging it right, that we need to tell always that all the big recent breakthrough like ChatGPT was possible not because of software but because of hardware, right? So semiconductors and how many transistors we are putting it, and in the future when we talk about agentic AI and edge AI, more intelligence at the edge level. Again, ECE will help in terms of enabling those intelligence, which requires again sensing, signal processing, security. Security is an important one. So cybersecurity has been traditionally a system problem, right? So we collect the data and we embed some rules, but we don't embed the cybersecurity all the way from semiconductor to the system level. And if you want to do that, ECE community will help. So getting into all those area and looking at the future, I think there's a lot to do in this area from the faculty.
And I feel like a lot of different departments across campus are working on different aspects of this. And so it's nice that the College of Engineering here has decided to kind of have a initiative to kind of do the collaboration and kind of maybe coordinate some of that, so that we're not going in all these different directions. And like you were saying before, someone might be doing something that we could be helping with and kind of helping with that. So I think that that's good too.
Mm-hmm. Yeah.
So thank you for spending some time with us this afternoon and visiting and answering questions. Before you go, would you like to have some words of advice for anyone who might be considering ECE? Like, why ECE? Why should someone consider going into electrical and computer engineering?
Sure, yeah. So I think if you look at the technology and where it's going to, that's what engineering is about, like making the technology change this world, right? That's why they're here in this department. So a lot of that is connected with EE and CP aspect. And, what will they do? It doesn't matter that they choose EE or CP or something related to that. They just need to focus on aligning their learning with, with the future aspect of where the field is going. And I think they will do very well.
Thank you. I agree. We can make a big impact.
Yes.
So thank you again for your visit today.